Now for this particular problem here, it's multi-steps. Um, give the coordinates of any critical points and classify each point as a max, min, or neither. Identify intervals where the function is increasing or decreasing. Give the coordinates of any points of inflection. Identify intervals where the function is concave up and concave down. Sketch the graph. What I would probably do is just go ahead and sketch the graph from the beginning, so I have an idea of what I'm dealing with. So we're given our original function here. So I find the first derivative and I find the second derivative here. Okay, so I want to find my critical points. It's going to be where f prime is 0, it doesn't exist. Okay, so in this case I set it equal to 0 and I solve for x. Divide by 6, so I have x squared is equal to 9. X is going to be equal to plus or minus 3. That's my critical point. So I'll find the y coordinates here by plugging back to the original function. So when x is negative 3, y is a positive 108. When x is a positive 3, y is a negative 108. So those are the actual coordinates of the where we may have a max or a min. But so now I'm going to see what it's doing as it gets close to those critical points, the behavior on either side of the critical points. Okay. So here it outlines the behavior of the second derivative using the critical points found in the first here. So using positive negative 3. So when I take that second derivative and I use a critical point, and I see that I have a negative number. So since it's negative here, I'm going to have a maximum. Then I test it out with the second derivative here, and I have a number that's greater than 0. That's a positive number, so we're going to have a minimum. Okay, so I'm going to have a minimum. So what we can do now is when we look at the graph, you can see that we can find out where it's max and a min. We already know that it's a max and a min on one side of it. Okay. So what we look at here is what's it doing on one side of, if we have a maximum here, a maximum at negative 3, on one side it's going to be increasing. Of negative 3 it's going to be increasing, and then the other side of negative 3 is going to be decreasing. Okay. And then from 3 to a positive infinity is going to be increasing again. So that tells us a little bit more. Now the next thing they ask us to talk about is giving the points of inflection. Points of inflection are where the concavity changes. So we find the points of inflection. We find the points of inflection by taking the second derivative here, setting it equal to 0. And this gives me a potential points of inflection. The y value when x is 0, y is 0. Okay. So at 0, 0, we have a change in concavity. On one side, it's going to be concave down, and the other side, it's going to be concave up. So at point 0, 0, that's where it changes. So along those intervals there, if you know the concavity changes at 0, 0, on one side of it, it's going to be concave down. And then from 0 to positive infinity, it's going to be concave up. You can see that from the graph, how the concavity changes. In the last part, I asked you to sketch the graph. You already have enough information here for algebraically to do it, and you've seen it on your calculator. So you know where the max and the min are, and you know where the points of inflection are. You should be able to sketch the graph. There's other things you can do too, higher level math, to find out where it's zero, and so on. But this is enough to sketch the graph.